Hi there and welcome to this video on Senior Physics for Motion. In this video we're going to explore displacement, velocity and acceleration using the PhET simulation. We're going to demonstrate how changing the velocity or changing the acceleration can have an effect on the graphs and try and incorporate what we've already looked at in our theory with respect to graphical representation to what happens in reality. Obviously this isn't a practical base, but it gives you a better understanding as to what's happening. So basically what I'd like you to do is, this is the website from PhET which allows you to download the simulation. I'll also put this link up on the post so that you can have a play on your own time. But what I thought we'd do is in this video we would run through the simulation and I'll try and explain what's happening with respect to displacement, velocity and time and acceleration, as a person is moving. So when we go onto the link, we get the following simulation which comes about. Now I'll just open the slide up, the file up, and there we go. Alright, so this is the introduction area, and basically we've got a guy and we've got a position, we've got a home, we've got a tree, we've got a brick wall. Okay, so basically we can do a variety of different things. We can change the position that our guy happens to be at, so we can move him in a negative vector. We can also move him in a positive vector, depending on how we want to look at our situation. We can change our velocity. We can get him going in a negative direction, or we can get him going in a positive direction. And again, this links quite nicely with our vector use. Okay, then we can change the acceleration which is happening. We can have them decelerating, or we can have them accelerating. So we'll just reset all these so we basically get things started. So that gives us an understanding what's going to happen. So let's start off very simply. We're going to position him at -10 away from home, and we'll give him a certain velocity, that speed, and then all we'll do is we'll press play. We're not going to get him accelerating, and you can see that this guy moves along. He's moving fairly slowly. Let's speed him up. Okay, now you can see the acceleration is changing, and then we get a constant velocity, and then he hits the wall. Okay, obviously this guy isn't very coordinated. Now on its own that doesn't really do a lot for us. What we'd like to do is to be able to see what's happening in a graphical sense. So if you come up to this area here, you can see we've got charts. Now what happens is we can alter the position, the velocity, and the acceleration as well. So let's do the same thing. Let's put his position right up at -10, and let's give him a basic speed. Let's have him going around about 2 meters per second. I'm going to keep my acceleration at 0 at this point. We're going to note what's happening with the graph. Now what happens is when I press play, I'm going to get a trace of what's happening with his position and his velocity. So let's press play and see what happens. So off he goes, and we're going to stop him when he gets to home. And we get a nice trace. There we go, he's at home. So let's have a look at our graph. Now we know that a distance time graph basically gives us an indication, the gradient gives us an indication of the velocity. Now if you look at our distance time graph, we can see we've got a gradient which is being generated. It's a slope. Now because it's a straight line, it means that we've got a constant velocity. Constant velocity means that we've got 0 acceleration. So if you look on the third graph, you can see we've got 0 acceleration. Now on a velocity time graph, a flat horizontal line will depict that basically we've got constant velocity. It's not changed from 1.927 meters per second. So automatically we can basically see what's going on. So that's quite useful. We can use the graph to basically determine the gradient of that blue line there will give us our velocity, and that velocity be 1.927. The gradient of this line, because it's horizontal, is 0, which depicts our acceleration. So that's pretty cool. Alright, well let's reset all the data. Let's do another one. So in this case, whoops, I'll just stop that there. Let's clear everything and let's put him at -10. So what we're going to do is we're going to get him accelerating, and we'll start from 0 and we're at position basically 10, and we'll have him accelerating at, let's have 2.2. Okay, that seems fairly good. So what we'll do is we'll get an acceleration which is generated. Now notice his velocity is going to start at 0. So basically what's happening as he's moving, we'll stop him there. Alrighty, so let's have a look and analyze our data. Right, now we know that he had an acceleration, and we know that he started at position 10 meters away from home, -10 meters away from home. Now, look what happens to the blue line. We're getting this nice curve. This curve is generated because it's accelerating. There's no constant velocity. Now look at the velocity time graph. Instead of having a horizontal, which denoted a constant velocity, we've now got a gradient. Now the gradient of a velocity time graph will give us an acceleration. And if it's a straight line going upwards on a gradient, it means that we've got a constant acceleration. So if we look down at the green line, we can see that we've got a constant flat acceleration. Now what happened was, as soon as he hit the brick wall, his acceleration dropped to 0, and then he bounced back again, back up to 0 acceleration once he bounced back off the wall. So basically what we've now got, we've demonstrated that we've got the curve in a displacement time graph denoting that the velocity is not constant. On our velocity time graph, we've got a nice straight line gradient, meaning that we've got a constant acceleration. And then a flat line on our acceleration time graph shows that we've got a constant acceleration again. So you can see now that this is quite a useful tool that we can start playing all over the place. Now we could have it going in the opposite direction. Sorry, I'll just reset it. And we can put our guy right over here, and we might have him going at this speed, and we can start playing, and you can see what's happening as we move around. We change the slope of the graph. Now you'll notice that on our displacement time graph that we've got a nice smooth straight line. We've got 0 acceleration, and we're going at a velocity of 5.78. Well, his velocity is constant, 5.78. This will be the same as the slope of the gradient on the displacement time graph. The only difference here is he's going in a negative direction. He's going in the opposite direction to the way we've started. And we can do exactly the same, and we can put we're moving back up here, we can put a acceleration in there. Let's have an acceleration there, and let's see what happens. Whoops, got him going in the wrong direction there. Alright, let's reset it all. Let's move him to away, and we'll have him going in that negative acceleration, and off we go. Watch him go. Alrighty, so again what we've got here is a constant acceleration. Look at the slope here. This slope here, the gradient, basically gives us the acceleration. It's this nice straight line, which means it's a constant acceleration. And then if we look at our displacement time graph, we've got a curve, but notice they're all going in the opposite directions. That's denoted by the fact that it's a negative situation. We're going from positive to negative this way, just meaning that he's going at velocity in the opposite direction. Okay, so I hope you found that useful. It's a nice little tool that we can utilize, and you can have a play and start changing the variables around, changing the position, the velocity and the acceleration, and as a result you should get an understanding as to how velocity time graphs, the displacement time graphs, velocity time graphs and acceleration time graphs all work together. Okay, well I hope you found that useful. Do have a go at playing with the link yourself, and check out some of the other interactive websites that I put on this post. Thanks for watching, and I look forward to you joining me again.